According to the U.S. Census Bureau, the world's population went from 2.5 billion in 1950 to 6 billion in 2000 and is on a pace to exceed 9 billion by 2050. A threefold increase in the global population since 1950 impacts the hard surface areas of our globe. As buildings and pavement expand, so do our obligations to control stormwater effluents. Stormwater is defined as water created by a precipitation event. This water passes through a wide variety of natural or artificial environments, often sweeping organic and inorganic constituents into the watercourse through storm drains. In most cases, this material reaches a stream, river, or other waterway, contributing to the overall pollutant load. On-site sampling and off-site testing can be completed after a rain event. A testing protocol to pinpoint the source, the contribution it is making to the pollutant load, and the proper course of action to take is essential. Discharges of illicit chemical constituents into storm drains represent a dry weather event. These outflows can contain a wide variety of both inorganic and organic contaminants and must be considered when characterizing the source of outflow. Inorganic constituents often provide indicators of such outflows when used in a manner that takes all indicators into account. Outflows attributable to a rainwater event can occur across a number of different environments. These include agricultural runoff, industrial sites, construction sites, irrigation runoff, and parking lots and pavement. Colorimetric methods measure the color intensity produced by a chemical reactant to an analyte. Measurement of this color can be through the use of test strips, comparators, or a colorimeter. Turbidimetric methods use an instrument to measure the concentration of suspended particulates in a liquid. A nephelometer measures suspended particles using a light beam and a light detector set to one side and/or directly opposite the source beam. Particle density is then a function of the light reflected and/or directed into the detectors from the particles. Titrations measure the amount of reactant added to a sample to create a color change. An endpoint titration starts with a reacted sample that changes color when a titration solution is added that shifts the pH of the sample. ISE is a transducer that converts the activity of a specific ion dissolved in a solution into electrical potential, which can then be measured by a voltmeter or pH meter. The sensing part of the electrode is usually made as an ion-specific membrane, along with the reference electrode. The US EPA recommends testing for the following indicators based on the MS4 permitting process and associated guidance. The indicators used for testing purposes can vary by state, depending on regulations. Illicit discharge detection requires additional testing for analytes of interest. Ammonia is a good indicator of sewage contamination. Its concentration is much higher in surface water than in groundwater or tap water. High ammonia concentrations may also indicate liquid waste from some industrial sites. Ammonia is easy to analyze, but dissipates rapidly. Its potential generation can result from non-human sources, such as pets or wildlife. Color is a numeric computation of the color observed in a water quality sample. Both industrial liquid waste and sewage tend to have elevated color values. Field testing has found high color values associated for all contaminated flows, but also many uncontaminated flows, which yielded numerous false positives. Overall, color may be a good first screen for problem outfalls, but needs to be supplemented by other indicator parameters. Conductivity, or specific conductance, is a measure of how easily electricity can flow through a water sample. Conductivity is often an indicator of dissolved material in water, known as total dissolved solids. Conductivity can be a poor indicator of illicit discharge in estuarine waters or in northern regions where de-icing salts are used. Conductivity has value in trend analysis to detect industrial discharges that can exhibit extremely high conductivity readings. Hardness measures the positive ions dissolved in water and primarily includes magnesium and calcium in natural waters. Hardness has limited value as an indicator parameter, except when values are extremely high or low. Hardness trend analysis may be useful in communities where hardness levels are elevated in groundwater due to karst or limestone terrain. pH is a good indicator for liquid waste from industries, which can have very high pH or low pH. The pH of residential wash water tends to be rather basic. Unusual pH data can identify problem outfalls that merit follow-up investigations using more effective indicators. Normal rainwater has a pH of approximately 5.6. Potassium is found at high levels in sewage and extremely high concentrations in many industrial process waters. Consequently, potassium can act as a good first screen for industrial wastes and in combination with ammonia to distinguish wash waters from sanitary wastes. Turbidity is a quantitative measure of cloudiness in water and normally measured using a simple field meter. Turbidity cannot distinguish between contaminated flow types, but is a useful indicator to determine if the discharge is contaminated. Ammonia forms a color complex with Nessler's reagent in proportion to the total amount of ammonia present in the sample. Color is determined by a meter that has been calibrated with colored standards of known platinum cobalt concentration. True color, the color after turbidity has been removed, is measured. Conductivity in water is affected by the presence of inorganic dissolved solids such as chloride, nitrate, sulfate, and phosphate anions, or sodium, magnesium, calcium, iron, and aluminum cations. Calcium and magnesium react in a strongly buffered medium with an indicator to develop a pale purple color in proportion to the concentration. pH is determined through the use of an ion-selective electrode. The voltage is theoretically dependent on the logarithm of the ionic activity. Potassium reacts with sodium tetraphenyl borate to form a colloidal white precipitate in quantities proportional to the potassium concentration. Turbidity is measured through the use of an absorptiometric 180-degree detector using visible light. Stormwater is generated by a precipitation event. Storm drains sweep contaminants from a wide variety of natural and man-made environments into the waterways. Various inorganic indicators can provide for screening of the outflow. Action levels and associated guidance have been established by the US EPA. Required measurements can vary state by state, as there are no federal government-mandated requirements. Making measurements is simple and straightforward using an MS4 screening kit.